So let's see what happens when we have two graphs and we want to find the area between two curves. Two graphs. Like this. And we want to find this area here. What are we going to do? Well, this situation is analogous to what we were doing when we were finding definite integrals. So we said, okay, we've got a curve. I want to find the area between x equals a and x equals b. So we're finding that integral. And what we said, we can take the area less than, so we get the antiderivative of b minus the antiderivative of a. That gives us our area under the curve. So we take the total area to the left of b, subtract the area to the left of a, and we get what's in between a and b. Here, we're doing the same thing. So if we've got function g of x, this function f of x, so g of x is the line, f of x looks kind of like a cubic. What we can do is, we've got between these two values of x, what happens is we can take the full area underneath f of x and subtract the area that's under g of x. And that leaves us with what's between the two curves. Okay? So all this down here plus the shaded area plus this hashed area down here is what's under f of x. And just this hatch mark there, that's the area underneath, g of x. And so the total area between the curves, that ends up being what's under f of x minus what's under g of x. And we can combine these, and we say taking the definite integral of f minus g of x. Let's take an example. Start with let's start. So we have the graph of y equals x squared. And y equals 2x plus 3. Okay? So we want to find this area between the two curves. Actually, I'm going to change this to g of x. I'll make the line f of x. So we want to find the area between the two curves. So basically, we've got these two values of x. X equals 3. And how I did that was solve the system of equations. What values of x are those two equal? So this factors is x minus 3, x plus 1, therefore x equals 3, x equals negative 1. That's where they intersect. So we want to find the area between those two. Okay, so basically we've got the area that's under the line. So between negative 1 and 3, we've got this entire area under the line above the x-axis. The area under g of x is down here. So if I take in this area, this trapezoid, and I remove what's under x squared, this area, what I'm left with is the area between the two curves. So it ends up, as we have down here, it's the integral between a and b of the top function, basically, minus the area below the bottom function, or just this combined function. So in our case, we're taking the integral between negative 1 and 3 of 2x plus 3 minus x squared dx, or simplified, the integral between negative 1 and 3 of negative x squared plus 2x plus 3. dx. Now, I'll clear a little bit of this out over here and solve this. So the antiderivative of negative x squared plus 2x plus 3, we're going to get negative 1/3 x cubed. Its derivative 3 times 1/3 negative 1 x squared plus x squared plus 3x. And we'll evaluate that between 3 and negative 1. So we get negative 1/3 times 3 cubed plus 3 squared plus 3 times 3 minus negative 1/3 times negative 1 cubed plus negative 1 squared plus 3 times negative 1. Or negative 9 plus 9 plus 9 minus 1/3 plus 1 minus 3 10 2/3, or 32/3 is our area. So here's what we get doing it this way. Just to check ourselves. Let's do it this way. Let's look at the area under 2x plus 3. And from that, we'll subtract the area under x squared. So we're going to find the area under 2x plus 3, so that will give us x squared plus 3x negative 1 to 3 minus 1/3 x cubed from negative 1 to 3. Doing a little bit of algebra, we'll see all the same numbers show up, so we'll get 3 squared plus 3 times 3 minus negative 1 squared plus 3 times that. So this gives us 20. That's the area under the line 2x plus 3. And then the area under y equals x squared is going to be 1/3 times 3 cubed minus 1/3 times negative 1 cubed, which ends up being 9 1/3. That's the area under the parabola. So to find the total area between the curves, 20 minus 9 1/3 gives us 10 2/3.